Good morning and happy snow day, AP Calcsters. Today we're going to do tangents of graphs of implicit relations and do some graphing calculator stuff. And then I'll tell you what'll be up for the rest of the week, because who knows what's going to happen the rest of the week. All right. What you need to know. When you have a horizontal line, you all know the slope equals 0. How do you get 0 for a slope? Well, in a fraction, it's going to be 0 over some number. Let's call it n. Okay? 0 over n gives you 0. So the numerator is 0. The denominator is not 0 for a horizontal line. If you have a vertical line, well, that's mostly vertical. Not that part. But if you have a vertical line, your slope is undefined. How do you get an undefined slope? Well, when you have like a number n over 0. So when you have a number over 0, it's undefined. So when the denominator is 0, you're going to have a vertical line. When the numerator is 0, you're going to have a horizontal line. And that's important when we're doing these implicit relations. Now, most of the time today, they will give you the first derivative. And remember, the first derivative is the slope. So that's your slope equation. Here's your original equation. Okay? They say find the y-coordinate where the point, find the y-coordinate of the point where the line tangent to the curve is the y-axis. Okay. So we're looking for like the function goes like that and it hits it there. It's tangent there. It hits it at one point. Something like that. Okay? So the point must be on the curve. So you need it to work in this equation. So this condition, the point must be on the curve, 3x squared plus 6x minus y squared plus 8y equals 16. Your point has to work in that equation, or else it won't be on this graph. Okay? Now, the second one is tangent to the y-axis. So the point must be on the y-axis. So on the y-axis, every value on the y-axis has an x-coordinate of 0. So the x has to be 0. Now when we look at the slope of this, the denominator must be equal to 0 because we're talking about a vertical line. Okay? Tangent to the y-axis, we're tangent to a vertical line. So the denominator must be 0. Okay? So y minus 4 must equal 0. And the numerator can equal 0 because then we have indeterminate form. And you can't have 0 over 0 because then you can't figure anything out from that. So 3 times x plus 1 cannot be 0. Okay? So we're supposed to solve the systems of equations. Well, this is a really easy one because this is easy to solve. Y minus 4 equals 0, so y must equal 4. That should be my answer, but I got to check, make sure it works in all these. Okay? So if y equals 4, if we stick 4 into here, we get 3x squared plus 6x minus 4 squared, which is 16, plus 8 times 4, which is 32, equals 16. Well, negative 16 plus 32 is 16. So 3x squared plus 6x plus 16 equals 16. If I subtract 16 from each side, 3x squared plus 6x equals 0. So if we factor out a 3x and we get 3x and then x plus 2 equals 0, x equals 0 or x equals 2. Okay? Well, we know that the point must be on the x-axis, so it can't be there. It has to be there. Y equals 4. If we put a 4 in and a 0 in, it'll work for the first equation. We already know x equals 0 there. We know that. If x equals 0, If we put a 0 into this, 0 plus 1 is 1, times 3 is 3. 3 does not equal 0. It works. So y equals 4 is my solution. Okay, let's do another one. Here's our function. It can be shown that the slope equals this. Okay, because that's the first derivative. And, maybe you should have to find that sometime, but it's too complicated. It takes too much time, so they give it to you. Okay, so we want to find the x-coordinate where the line tangent to the curve is the x-axis. So if it's tangent at the x-axis, the curve, goes like this, but it actually touches it somewhere here. Okay, it hits it somewhere like that. So what do we know? Well, we know that 4x squared plus 48x plus 9y squared minus 36y equals negative 144, the original function. If it's at the x-axis, it has a y value of 0. So we know that's a true statement. If it's a horizontal line, okay, because we want tangent to the x-axis, so it's tangent. So if it's a horizontal line, the slope is 0. So we know the numerator, 4 times x plus 6, has to equal 0. And we know the denominator, 9 times 2 minus y, cannot be 0. So those are the 4 things that we know have to work. Well, this is where we start. What one equals 0? If 4 times x plus 6 equals 0, then x plus 6 equals 0 if we divide both sides by 4, and x equals negative 6. Okay, so this point should be at x equals negative 6 and y equals 0. Okay, that should be our answer. I mean, those of you who like to guess, could plug that in right away, and I would bet you're right. But if you want to check your answer, you stick it into this function. So, clear. I'm going to take 4 times negative 6 squared plus 48x, 48 times negative 6, and see what that equals. That equals negative 144. So, negative 144 plus 9y squared minus 36y equals negative 144. So if we add 144 to each side, 9y squared minus 36y equals 0. If we factor out a 9y out of that, we get y minus 4 equals 0. So y equals 0 or y equals 4. Well, we know that doesn't work. We need the y equals 0. Y does equal 0 in this instance. X equals negative 6. So it checks here because it works in that function. It checks here because I have one that works. It checks here. And then if y equals 0, this does not equal 0. It checks here. So x equals negative 6. Now we want to find the equation of a horizontal line that's tangent to the curve and is above the x-axis. So it has to work in the original function. 3x squared plus 4y to the 4th plus 6x equals 253. Okay. It's above the x-axis, so the y has to be greater than 0. Okay. Y cannot equal 0 because that would be on the x-axis. Y has to be greater than 0. If it's a horizontal line, negative 6 times x plus 1 has to equal 0, and 4y cubed cannot equal 0. All right, so this one's the first we pull. Negative 6 times x plus 1 equals 0. Divide both sides by negative 6, x plus 1 equals 0. X would equal negative 1. Okay, so you want to have an x value of negative 1, and you want your y value to be positive. Now if we stick negative 1 into this function, 3 times negative 1 squared plus y to the fourth plus 6 times negative 1 equals 253. Okay, so we get 3 minus 6 plus y to the fourth equals 253. So negative 3 plus y to the fourth equals 253. So y to the fourth equals 256. I was thinking ahead on that. Okay, so if y to the fourth equals 256, what's the fourth root of 256? Well, you type in 256 raised to the 1/4 power, and you get 4. So y must equal 4. Okay? So the equation of a horizontal line is always y equals a number. So y equals 4 is a positive number. It'll happen at negative 1. It does not equal 0 for this, and it works in this function. Okay? So that's how you do these. You just solve away. Now, Kendall tried to find all the equations of vertical lines tangent to the curve given by this function. This is her solution. So she did the first derivative by using implicit differentiation and found that. Then she formed her systems of equations, okay, where if it's going to be a vertical line, the denominator has to equal 0, the numerator cannot equal 0, it has to work in that function. So if you do that, she said, well, she found this, this, and this for answers. Okay? Now, are those all the answers? Well, if we check the answers here, I know that 2xy must equal 0, so that's either x equals 0 or y equals 0. But I know they both can't be 0 at the same time because it wouldn't work in there. Okay? Now, if x is 0 and we stick it into this first equation, we get 0 squared plus 2 times 0 times whatever for y equals 25. I know that x cannot equal 0 because we have 0 plus 0 equals 25, and that cannot work. So I know x cannot equal 0. Okay, so since x cannot equal 0, she said x equals 0, we know that her third step is incorrect. Okay, all right, so you'll have to say correct or incorrect. So you'll get some practice at these. If you get a couple wrong, you get a couple wrong, and you'll figure it out later. Now, you'll do a section on graphing calculator stuff. Here's a graphing calculator. You know, it says use a graphing calculator. So I will assign a graphing calculator section to you, and it'll ask you questions like this. The second derivative of the function is this. Where is it concave down? Well, when the second derivative is greater than 0, it's concave up. When the second derivative is less than 0, it's concave down. So if we graph this thing, x to the fourth minus x squared minus x, if we graph that, we see that it has a little area right here that's below 0. Okay? So we want to know where it's concave down. We want to know where the second derivative is less than 0. It's less than 0 in between here and here. Not this one. Not this one. Not this one. But it sure looks like this one. If I zoom in a little bit, yep, it looks like it's between 0 and 1.325. if I trace to 1.325, I'm really close to 0. Okay, so that works. That should be the answer. Here they ask the second derivative of the function. How many points of inflection does it have? Well, remember, points of inflection are when the second derivative, I guess it's f of x for this one, where our second derivative is equal to 0. Okay, so we're going to graph this thing. So I go y equals, clear this out, and I'm going to go sine of x squared plus cosine of 2x minus 1/2. I'm going to graph this. So I'm going to graph, and that doesn't look very nice. So then I'm going to go into my mode and make sure I'm in radian mode. And now if I graph it, oh, now it looks like a curve that I'm used to. Now, we're looking for where it crosses between 1 and 4. So I got to change my window here. Let's change it so it goes from -2 to like 6 and graph it. So then I can see from 1 to 4. So it crosses 1, 2, a few times. 1 is right here. So it crosses just before 1. Let me change my window again to like 0.9 to 4.1. So it's a little more zoomed in on it. So it crosses just before 1, so we can't count that, but we count this one 1, this one 2, this one 3, and this one 4. It crosses it at 4 times, so it has 4 points of inflection. Okay, that's how you use your graphing calculator to calculate out these complicated ones. All right, how many extremum points does it have between 1 and 5? Well, extremum points are mins and maxes. Where do you have a min and max? Okay, where you have extremum points, where the critical numbers equals 0, where the first derivative equals 0 are your critical numbers, which are your extremum points. So let's graph this thing. And now we're going between 1 and 5, so I'm going to change my window to 5.1 here. And then after that graph, that's the old graph where it crosses 4 times. So y equals, clear out this graph, and I'm going to go 3 sine of x plus the natural log, which is right here, of x. And I'm going to graph that thing. And we're going to see that it crosses once. It just crosses once in between there. So it has 1 extremum point. Okay, when the first derivative is equal to 0, then we're going to have 1 critical number there because it crosses the graph 1 time. Where is this graph decreasing? Well, we know it's decreasing when the first derivative of the function is less than 0. It's decreasing because it has a negative slope. Where the first derivative is greater than 0, it's increasing. Okay, so we take this function and we're going to go y equals, clear out what's there. I'm going to go second e to the x minus x cubed. Oops, Mr. Bierschbach. Whoa. Let's try that again. I'm going to go e to the x, slide over, minus x cubed. I'm going to graph that. And I got to figure out where it's decreasing. Where is this negative at? Well, let me change my window. Let's go zoom 6, and I'll get back out to the normal window. Where am I negative? I'm negative right in between there and there. So at like 1.8, 1.9 right here, and 4.5. So it's this one. Okay. Where is it concave up? This is our last one we're going to do here. So where is this concave up? Ooh, I'm given the first derivative, not the second derivative. So if you have to figure out where it's concave up, what you have to do is find the second derivative of this. What is the second derivative of the ln of x times x? Well, looks like we have to use the product rule. So the second derivative is the ln of x times the first derivative of x, which is 1, plus x times the first derivative of the ln of x, which is 1 over x, which this cancels to be 1. So it's the ln of x plus 1 is the second derivative. So if we go and graph that, clear, the natural log of x plus 1, and we graph that. Where is it concave up? Well, where is the second derivative bigger than 0? Well, it's after that point. Okay, so if we go window and we make it 0 here and graph it, we'll be a lot closer. So it's going to be like 3.68 after 3.68. But what about less than 3.68? Well, this isn't negative ever. But since it crosses at 3.68, I'm going to make an educated guess that this is going to be the answer. And that some of our solutions probably disappeared when we took a derivative here. But since we get this, because if I go 3.68, or nope, clear, 0.368, and if I enter that, I'm basically at 0. Now, let's change my window back to zoom 6, back to the normal window. I don't think it'll give me an answer for negative 3.68 if I trace that in. So if I go trace negative 0.368, yeah, there's no answer there because I think when you took the derivative, we may have gotten rid of solutions there because of the absolute value here. So the absolute value has something to do with it. So I would say D is the answer. Okay, so what's up? Well, today is Tuesday, snow day. But on our snow day, we're still going to do some stuff. We're going to do this. We're going to do this. And you got a quiz. Okay? So you have those things to do today. Assign. And you started on December 13th. Let's give you till Friday to get that done. Okay? And then those are out now. And then what else? Well, Thursday, well, let's call this Wednesday. If we come back to school Wednesday, I already talked to Shaw and I begged for him to have a B day on Wednesday because we had 2 straight A days. Because Thursday is 40-mile-per-hour winds and 1 to 3 inches of the fluffy white stuff. And so we might not have school Thursday as well, which will be another gone B day. So I told Shaw, I want a B-Day that day so we can see you people and I can impart some of my vast knowledge onto you. Okay? Because Friday, I think we'll have school. And so I don't know if that'll be a C day or a B day or what Friday will be. So we'll just have to make things work. Okay? So whatever we do next week, Monday, we'll review for the AP classroom test. And Tuesday, we'll take the AP classroom test on chapter 5. Okay, so that means somewhere in here we need to take the Khan Academy Unit 5 test. So somewhere we'll have to take the Khan Academy test. We'll have to do a little review for that.